Good afternoon, ladies and gentlemen. Thank you very much for allowing me to come to speak to you today. I would like to share with you my holistic overview of the concept of actually whether we can actually get robotics to work within fish processing industry, particularly here in Scotland. To understand whether we have the technical developments and we've actually bridged that gap in technology that robotics can now start to replace or to help the fish processing sector move forward, and really what are the potential opportunities that exist for us as we move into the technology. Basically what I want to look at is obviously, can robotics work within the fish processing sector? Sorry, I should move that forward. Get them out of the way. The historical application of robotics, basically the application of robotics has been successfully achieved in many industries, as everyone can see from TV and different things, dealing with well-defined processes and products. The thing about robotics is the fact, unless something is really well-defined, the robotics won't necessarily handle it too well. So it's got to be specific, beg your pardon, it's got to be specific, and that's how the robotics will actually work with it. Within meat, fish and poultry, it accounts, sorry if I keep forgetting to move this forward, meat, fish and poultry accounts for a considerable proportion of the food consumed worldwide. If you look at the statistics, from 2018, poultry around the world is 13.8 kilos, beef is 10.2 and fish was 22.3 kilos. If you look at the anticipated volumes in 2030, then you're looking at 17.2 for poultry, beef moving up to 17, and fish continually growing between 2 and 3% to 24.5 per capita per kilo of fish being consumed. Sorry. So fish processing production using robotics did not lend itself to automatic methods due to variability, flexibility, and some of the products. It just didn't really fit in terms of the 10 or 15 years ago. In terms of where we're at now, recent reviews reveal that the food processing sector is the new potential area, basically, in which ample opportunities exist by integrating advancements from various technology domains. So there's a number of companies who have got together between fish, meat and poultry who are working collaboratively to try to put together some new technology that can actually fit across the whole of the food sector. It's widely anticipated that through dissemination, research and development, the robo-food, as they're now calling it, will stimulate collaboration amongst technology and the food processing community, which is well underway at the moment. One important innovation in robotics is cloud connectivity. They communicate with each other and make adjustments to their programs to be more efficient. Robots are essentially becoming smarter. Robotics being used in other proteins. Automation and use of robotic technologies are developing faster within meat and the poultry sectors. They have been probably 5 or 6 years ahead of the fishing industry, particularly fishing processing industry. The seafood processing industry has a relatively small robotic involvement, but I believe it needs to increase this involvement in spite of the perceived challenges regarding robotic handling of fresh products and hygiene requirements. Obviously, the goal for all the businesses is to reduce production costs and increase the product quality of the products we're actually producing. Just log on this one. Why the move to robotics in the meat and poultry sector? I think it's obviously quite clear it's the same within the fishing sector, but difficult in recruiting and retention of staff. The Brexit, the unknown impact of the EU and non-EU citizens. The gig economy, where the fact that 0-hour contracts are now becoming more questionable by people who want to be given guaranteed hours or substantive contracts rather than just actually working on just in time sort of turn up for work, which obviously suits the fishing industry at the moment but may have to change. Agency costs of actually bringing in those employees on a need basis, and also the national living wage and the living wage pressure. We all want to pay people a good rate for the work they do, but at the end of the day, it's obviously putting pressure on all the processors to maintain that level of living wage and the national minimum wage. In terms of the fish consumption in the UK, The fish consumption in the UK is estimated at 410,000 metric tonnes in 2019, and also the fish consumption in UK adults rising to around 500,000 metric tonnes by 2030. Do we have the staff? So I think it's the same theme that's running through all of the people who are doing the presentations. In terms of the Scottish fish processing citizens, again, as Lewis is obviously my graph slightly out of date because it's probably about a year older than Lewis's, but we still have, you can see quite clearly, a high dependency on EU and non-EU citizens, basically for processing within the fish sector within Scotland. In terms of the application of robotics in the meat and poultry sector, they use it for decanting. Obviously, they can decant all of the boxes of chickens that come in, or pork, pick and place, deboning, repacking, further processing, end-of-line palletising. If you look at the challenges of robotic technology in primary processing, the challenges basically of integrating robotics into primary fish processing is that raw materials coming into the pipeline do not basically have standard dimensions that can be programmed into a robot currently, because unless everything is actually, I keep hitting this, sorry, unless everything is actually put together and they're all of an equal size, it just necessarily can't handle it. It may handle 90% of it, but you may spend more time picking up the pieces that need to be obviously put back onto the packing line. Examples of robot design, if you want to attach a door basically to a car, it can easily program this door to actually fit it onto a car because that's quite straightforward and can do it quite easily. A robot design to peel an apple is more challenging because there's no two apples got the same dimensions or size, so therefore that makes it more awkward for it. In terms of primary processing success in robotics, one primary process where robotic technology has successfully been integrated is in chicken leg processing. I recently worked with an R&D company in Holland, in a place called Nijmegen, who were developing a chicken factory to run on robotic systems. My background has always been in poultry, and I also worked with Marshall Food Group for many years. And at the plant at Newbridge in Edinburgh, we employed 2,500 people, and we processed 800,000 chickens a week that were sold to various retailers. The factory in Nijmegen that has just really been finished recently is processing 1.2 million chickens per week and is using 250 people, and it's all robotics. So that's the difference between using robotics and technology. So there's opportunities there. The dimensions of chicken legs have small variations, so many companies have developed an assembly line system, deboning 100 pieces of chicken's legs per minute. For me to employ that in a chicken house, that would be 33 people I would have to employ to do 100 legs. But these machines are actually doing 100 a minute. Much more efficient now in keeping up with the growing popularity of chicken legs worldwide. Again, it's like fish. There's obviously bits that you don't need and you try to sell on. Within chicken, everyone wants to buy the breast meat, no one wants the leg meat, so you have to obviously find ways of actually moving the leg meat at the same time as trying to balance up your breast meat. Robotics technology, primary beef butchery. Beef carcasses are very varied, obviously, in shape and size, and the human butchers basically rely more on touch than sight. If you see a butcher actually deboning a side of beef, he's actually feeling for the various types of cuts in salmon and all these different things, and the steaks we actually know what we're eating. A meat processing company in Brazil is actually now investing in robots that can together break down the beef carcass. One robot is sort of programmed to create a 3D model of each carcass with the robotic arms to be used to a reference point, and obviously then cuts out to the different sections of the beef. And the process also includes the robots designed to sort and pack each individual cut at the end of the production line. The benefits of using robotics in fish processing, the benefits of using robotics in secondary processing primarily at the moment, are particularly attractive in repetitive processes. So if it's a repetitive process like, for example, cake decoration, chicken deboning, pizzas, final pack and tray fill, form fill pack place, pick and place, red meat final pack and palletising, lots of areas where that technical gap, perhaps when I was working within the various fish and poultry sections, I didn't believe that gap could be actually taken any further, because you've now got in the fish section as my colleague before me mentioned, the fact you've got the water jet cutters, you've got the pin bee boners, you've got all the different things that can actually enhance the technology behind that. But it's moving on. So the challenge facing the fish processing sector, the learnings that we have got from the people who are currently using robotics is the challenges of robotic technology in fish processing and primary, secondary largely depends on whether the products need to be either delivered continuously, which obviously helps robotics in terms of that process, or whether in fact they're in batches, because robotics are not particularly good if in actual fact you're stopping and starting, stopping and starting. So if you've got a production line that runs for 24 hours, 5 days a week, robotics is probably something you could look at in terms of trying to advance your overall technical ability going forward. Giving robots the ability to assess each individual raw material before processing is key primary process. So in other words, if you can actually take photographs, which is now new technology available now, where they can actually photograph every piece of fish that's passing by, and it can send it to a different line, and it can actually get a different robotic arm to pick and place it inside a packet. So there is new technology out there that's actually moving forward at a pace. Whereas I think that, beg your pardon, giving the robots the ability to access each individual raw material before processing is key to primary processing, whereas training employees to work alongside the robots has been a bigger challenge for the secondary processing sector. I mean, if you look at coating lines, for example, within the fishing sector, where if you're actually doing a ton an hour of scampi tails going down a production line, it could take you 33 people to pack this product from start to finish. The new robotic system that's being used, in actual fact, can now use, I think it's 5 people, and that's the difference in terms of doing that. You can't go any faster because you're restricted to the fryer temperature, and you're also restricted to the fact the freezer temperature's got to be maintained at a proper level. But there are benefits in terms of applying robotics to even coating lines now within the fishing sector. But it's about training the staff to work alongside that. So one of the pitfalls that the Dutch are finding is the fact they can't necessarily get the staff to match the technical ability that the robotics need in terms of the programming. So there's been a lot of education required in terms of developing the skills of the staff. As a whole, the fish processing sector needs to confront not only where robots could be a beneficial investment, but also how to transition its employees out of the roles of robots which are now taking over. Their colleagues before me have talked about the fact about we haven't got enough staff, but you can also put something into technology that can actually reduce the staff. But at the same time, what it's really saying in terms of the learnings from these factories abroad is that you've got to retrain the staff to be able to cope with the new technology that's actually available. What will our workforce look like in 10 years from now? 10 years from now, a lot of the things that our employees do today will be fully automated. And I think in many ways it's a challenge for the better and creating opportunities for businesses and staff collectively. I think technology and automation increases efficiency and allows staff to put their skills to better use to maximise the productivity, which we're all about to deliver. The future in fish processing. The first 3 industrial revolutions came from steam, electricity and computing. I think the fourth in the shape of robotics and automation. I think that's actually moving that way as we go forward now. And are we ready for it? I think new technology standards were seen as an inhibitor. We now recognise them as a starting point for improvement. That was Henry Ford in 1926. So you can see that obviously then they were still looking for opportunities to develop as we move forward. So just looking at my last piece here. In terms of what does it mean to the fishing sector, the fish processing sector, in terms of technology, in terms of robotics, well, it's to maximise the productivity and throughput. It's a reduction in direct labour is obviously the main theme behind it. There is a high initial investment. My colleague obviously spoke about investing lots of money to try to get a return. If anyone's looking for a quick return on the capital invested, it may take you where it may take some of the sort of projects I've worked on in the past, may take a year and a half to get the payback. I think in some of these projects that I've looked at, you're looking maybe 5 to 10 years before you get a payback on some of the investment you put in. And also there's a high maintenance cost in terms of training and programming, in the sense of making sure that everyone is fully up to speed with what they actually do. I've also in my presentation listed 30 different companies. That's not particularly one company is better than another, but there are lots of companies now out there who are working collectively within the food sector, sorry, who are all working collaboratively to try to improve the overall picture of robotics and how it can actually take us forward as we move into the next sort of 2020, basically, or 2030. So I don't have specifics to talk about. I'm just giving you a concept of an overview, a holistic view of what robotics can do and what it's currently doing out there in Europe. And I think the fishing industry has really got to grasp it now to say, well, look, we're not going to have the staff. We're going to have difficult recruiting staff. But do we have the money and the funds to try to invest in this? And that's where perhaps the government can also come in to help support processors in the sense of actually investing in new product development and technology for the future. Okay. Thank you. Thank you.